Welcome to Linearizing Data and Logarithmic Graph Paper Problem Sets. The first problem is for the exponential functions in problems 1 and 2. A. Calculate the y values for the given values of x. B. Plot the points on the add, multiply, simulate graph paper. And C. Show that the points lie on a straight line. So we have three requirements. Let's begin with taking the y values for the given values of x. Okay. So we have how many values of x here? 1, 2, 3, 4, 5. So we must have at least 6 cells for each rows. 1, 2, 3, 4, 5, 6. Okay, that's enough. This is my x and this is my y, and my x is 1, 3, 5, 7, 9, and my y are, if my x is 1, then for this function y equals 1.52 raised to x, then my function would be, my x is 1, that's 1.5 times 2 raised to x, it would be 3, and then 12, and then 48, and then 192, and then 768. Okay, this is for letter A. So we did letter A. Plot the points and add, multiply, simulate graph paper. So I'm just going to show you how to plot it on a similar graph paper. So this is for B and C, and we are to graph it on a similog. So note that the similog has logarithmic scales on the vertical axis. So if my x is 1, my y is 3, so it's here, right? Okay, so let us graph again a point. So we have this point. If my x is 3, I will have 12, so it's here. And if my x is 5, then it's 48, so close to 50. My x is 7, it's 192, so it's here. And then if x is 9, 768, so it's here. And notice that it will follow a straight line. Okay, so noting all of these all of these points, and graphing will just give us a straight line. Okay, so this is for number 1. Let's go to number 2. Of course, we are going to graph plot the points for number 2, which is 800, 0.6 raised to x, which is an exponential function. So same thing, we have 2, 4, 5 x values. That means we have to make at least 6 rows of cells. Okay, so this is enough. We will have x and y. This is my x, and this would be my y. Okay, my x is 2, 4, 6, 8, 10. Using a scientific calculator to solve for our y, then if my x is 2, my y is 288. So this is 288. My x is 4, it's 103.68. My x is 3, that would be 37.3248. My x is 8, that's 13.4369. If my x is 10, I have 4.8372. Okay, so now it's time to plot the entire points on a similar graph paper. So this is how it will look like. Okay, now plotting the points. My points are 2 and 288. So 2 and 288. So it's here. I need a bigger point. So it's here. And then 4 103.68. So this is 4 103.68. So it's little above 100. 637.3248. So it's going down, it's decreasing. Okay? And 813.4369. So it's here. And then 10, it's 4.8372. So it's way little below the the y is equal to 5. And then we have to connect all of the points. So connecting all of the points will give us this straight line here. So therefore, we have solved for B and C, right? B we have B and C. Okay, that's for the first two pairs, the first pair for our problem set. We now go to another pair, which is that of power functions. It's not exponential functions, it's power functions. So this is now power functions. Okay, so first calculate the y values. So the same thing as with the first example that we just undertook. Okay, B, plot the points on log-log graph paper. C, show that the points lie on a straight line, and measure the slope with a ruler and show that it equals the exponent in the equation. Okay, so let us have the points. So our x is 1, 5, 10, 30, and 100. Let us write it here. So 1, 5, 10, 30, and 100. And according to my equation, my function 700x raised to negative 1.3. So my x is 1, then my y is 700. If my x is 5, then I have 86.3847. If my x is 10, I have 8.4108. So it's decreasing again. Okay. If my x is 30. Okay, I think I made a mistake here. This is supposed to be x is equal to 10. Okay, if x is equal to 10, that's 35.0831 for the y. Okay, if my x is 30, that's 8.4108 for the y. And if my x is 100, that's 1.7583. So now let us see the graph on a log-log graph paper. Remember that log-log graph paper is used for power functions. So let us replot the points. My first point is 1 and 700. So there is a y-intercept here. Okay. Next we have 5 and 86.3847. So it's here. Okay, and then 10 and 35.0831. Okay, so it's in between 20 and 50. Next we have 38.4108. So it's here. And then the last one is 101.7583, approximately, something like that. And I could now draw a line, connecting all of the points there. So that would give me actually a straight line running through all of the points. So this is my line. Okay. Let me just clarify all the points. Okay, that's it. So as you can see, we have a straight line. Now how do we measure the slope of the point? We have two methods here. We could either use the formula for the slope, which is m is equal to y2 minus y1 over x2 minus x1. And we can just choose 2 points here. So I'm going to choose 1700 and 586.3847. This is my y2, this is my y1, this is my x2, this is my x1. So I will have 86.3847 minus 700 divided by 5 minus 1. So it should be negative, right? And let me see. So 86.3847. Okay, oops, we can do this thing for slope because yeah, I remember this is a power function. If we are going to use this, then it wouldn't be a straight line. So instead we're going to use a ruler, okay? And that is the requirement of our what do you call this? That is the requirement of this question, of this problem. So we can't use this slope formula here because if we're going to take the 2 points here, it would not yield the same slope as in here. Okay? Okay, to get our slope, I have a calculator here. I mean a ruler, and this ruler, not calculator, okay? This ruler will be used to get the slope of this line. So I can actually get the slope by considering 2 points here. So, but instead I want to get the slope of the whole line here. Okay, so I will begin with 0 going to, what is this? This is 1, 2, 3, 3.1, 2, 3, 4, 5. So this is 3.5 for the y, okay? And I will divide it by the difference in the x. So I will, okay, put this into 180. So now we are on the 180. So I'm gonna put this down, and the difference is 3.5, and this is 1, 2, 2.8, I guess. Okay, so this is 2.8. So let me see approximately if we are going to 1.3. So 3.5 divided by 2.8 is equal to 1.25. So approximately, this is approximately 1.25 or approximately 1.3. So we get a slope of 1.3. But wait, this is decreasing. So our slope should be negative of 1.3. Okay. So we get the slope of this line. Okay, so go to the next example. Okay, we have number 4, y is equal to 5 times x raised to 0.8. So as usual, we should get the values for the y first, and then we will get the graph and see whether this is a straight line or not. So let's begin with the points. And my x values are 1, 6, 10, 40, and 100. Okay, what is my y for x equals 1? If I'm going to substitute 1 here on this function, then my y is 5, and next my y is 20.9648, and then I have 31.5478, and then I have 95.6352, and then if my x is 100, I have 199.0535. Okay, next I'm going to plot the points. So consider this semi or log graph paper. Okay, so let us plot the points together. If my x is 1, then my y is 5, and then 6, 20.9648, 10, 31.5478, 40, we have 95.6352, and lastly we have 100, 199.0535. So it's here. And then joining all of the points, so I'll just draw a straight line running from here going to the last point and extending. Okay, so you can see that we have a straight line here, right? Okay, just to emphasize the points, these are the points. Okay, so once we have this graph, we could tell that this is a straight line following the log graph paper. So for letter D, to measure the slope, it's the same thing with what we did last time with this example in getting this slope. So we got 1.3, that's approximately negative 1.3 because it's decreasing. Now if you are going to use the same method, then this will give us an approximate slope of equal to 0.8. Now this time it's positive because it's increasing. Okay, it is increasing. Okay, next, this is our last set of examples or problem sets. So for the log function, this is log function, this is not exponential function. Okay, this is log function. Log function. In problems 3 and 4, calculate the y values for the given values of x, plot the points and multiply, add semi-log graph paper, and show that the points lie in a straight line. So number 5, y equals 2 plus 3 ln of x, where our x is 1, 4, 10, 200, 1000. So for number 5, this is our table. Okay, if my x is 1, my y is 2. My x is 4, my y is 6.1588. 10 for x, 8.9077 for y. X is 200, 17.8949 for y. X is 1000, 22.7232 for y. And then we will consider graphing, or we are actually graphing the points. So 0, it's, or I'm sorry, if it's 0, then we will have, what do we have here? If x is 1, then we have 2 for y. So we have 2 here. And then if our x is 4, 6.1588. So our x is 10, 8.9077. If x is 200, 17.8949. And if x is 1000, 22.7232. And then we'll just connect the points. So connecting the points gives us actually a straight line. Right? Okay, so it's proven. Okay, now I have to emphasize my points. Okay, these are my points. So we answered number 5. Let's go to number 6. For number 6, we have the same process. This is not exponential. This is not exponential. This is log functions. Okay. So for 6, that's y equals 1 plus 2 log x. And my x is 3, 8, 20, 100, 500. So these are my x values. And solving the y values, following this equation, I will get negative 0.0457, 0.8061, 1.6020, 3 and 4.3979 respectively. And plotting the points, now I will have these points. So if my x is 3, then negative 0 points. So it's below 0. Okay, then my x is 8, 0.8061. X is 20, 1.6020. X is 100, this is 3. And then x is 500, 4.3979. And then connecting all of the points together, I will get this. It's pretty a straight line, okay? So just to graph them again. I mean, emphasizing the points. So this will have this, and this. Okay, so this is the end of the problem sets for chapter 3, lesson 4, linearizing data and logarithmic graph papers. So I hope you enjoyed the videos, and I hope you were clarified. And again, thank you for watching and listening, and have a nice day, everyone.